So example 2, parabola is equidistant from the point 3, 4 and the line x equals negative 1. So let's talk about this, the wording of this one. Parabola is equidistant from a point and a line. So if we go back here to this picture, this purple thing here is the parabola. It's the same distance from a point and a line. The definition of a parabola talks about the distance from a point and a line. Every point on this parabola, if I was to say from here to here is some distance, we'll call that d sub 1. And from here to here is some distance, we'll call that d sub 2. Those will be the same amount no matter where I'm at along the parabola. It's the set of all points equidistant from a point and a line. The point and line is equidistant from are the focus and the directrix. So when they word it like this, and they say a parabola is equidistant from some point, the point they're giving you is the focus. And some line, the line they're giving you is the directrix. So some problems are going to say, hey, the focus is this, the directrix is this. Other problems are going to say, hey, it's equidistant from this point and this line. They're still telling you the focus and directrix. Right? Now, when an equation of a line says x equals number, that's a vertical line. So the line of a vertical line equation is always going to be x equals some number. X equals 1, or sorry, negative 1. So x equals negative 1, you go 1 left, you're free to go up and down at will. So my directrix is x equals negative 1, so I'm going to draw that. There's x equals negative 1, that's the directrix. Put a d next to it. The point 3, 4 is the focus. Starting at the origin, 1, 2, 3 right, 1, 2, 3, 4 up, that's my focus. Okay. Just like the other problem, the directrix is going to be perpendicular to the axis of symmetry. So I can graph the axis of symmetry so that it goes through the focus and it goes perpendicular, so horizontal, through the focus like so. So just like the last problem, I can very easily identify from the focus and directrix given, the axis of symmetry should be right there, perpendicular to the directrix, through the focus.
How did you know that the directrix has to go on that negative 1?
It says x equals negative 1 here. So when you have x equals number, so here's my x-axis, I go up to negative 1.
Okay.
And then y is free to be what it wants to be. So
if it said y equals negative 1, would it go below?
yeah, if it says y equals negative 1, I go down to negative 1, now x is free to be what it wants to be. So again, going back to the other problem real quick, horizontals always have y equals number, verticals always have x equals number.
Okay.
And the directrix, we're not going to do any slanted parabolas, that'd be mean. Yeah. Those are hard. All right, we do cover those in the latter half of geotrig if we get to it. Sometimes we don't. But every parabola we're going to have is either going to be straight up or down, so the directrix is going to be horizontal, or straight left and right, so the directrix is going to be vertical. So you expect your directrix to be an x equals or y equals equation every time. All right. So the vertex is halfway between the focus and the directrix along the axis of symmetry. So I can see the distance here from here to here is 4, so half of that's 2. So my vertex is going to be 2 away from the focus, 2 away from the directrix, so my vertex is going to be right here. So it says, what is the vertex of the parabola? I'm going to see that is 1 right and 4 up. So vertex is 1 comma 4, which again tells me that h equals 1 and k equals 4. That's what the vertex does for me. It gives me the h and k that I need to write my equation. Part B, is the equation in the form x minus h squared or y minus k squared? So the vertex and focus are here, so that means the parabola is going to be turning to the right if I graph it. So that's a y minus k squared version, so it's this standard form, not that one. Okay, again, once you establish, I usually do it by the directrix. My directrix is vertical, the parabola goes left to right, y is squared.
How did you get 1 over, I'm at 1, 4, 1 and 4?
1 comma 4. Once I establish where the vertex was, because 4 across here, so half of that's 2, so 2, 2, so we get the middle point along the axis of symmetry. Then you start at the origin, you go 1 right, 1, 2, 3, 4 up.
Okay.
So just whatever the x coordinate 1 and the y coordinate 4 are, is the ordered pair.
Thank you.
All right. Part C, what is the focal length? Focal length, again, is the directional distance from the vertex to the focus. So we start at the vertex, we go to the focus. Which direction am I going? right, which is positive, how far?
2.
2. So P is equal to positive 2. So I know the vertex, I know the focal length, and I know the proper structure. Once I know all those things, now I'm ready to write the answer. So I'm going to write it in this exact order. Something squared with y in it equals something times x minus something, right? So that part's always the same once I've established standard form, right? Whichever I'm going to use. Minus k, k is 4, so minus k is minus 4. Be careful, y is with k, x is with h in both of these standard forms. Okay, so make sure k goes with y. And then it says x minus h, h is 1, so x minus 1. And then it says 4 times p, right here. P is positive 2, so 4 times positive 2 is positive 8. If p happened to be a negative 2, this would be negative 8. So the sign of p matters as far as the standard form you create. This would be the standard form of the parabola. And again, that's what we're looking for. This is the technique. Right now I'm going to kind of walk you through it like this, but eventually I'm going to expect you to be able to do all this stuff. You need to know the vertex, the focal length, and which standard form. Once you have that information, you can just write your answer out.
So like on our practice problem, they